All right. Okay, it's 4 o'clock. Let's get going. All right, so let's also get the laser pointer on. Okay, assignments due. You should get that done. If you're working on it during class, I know some people are. Okay, that's all right, but just don't talk. Because in the last class, there was people talking, and it just really started to boil my blood. I'm trying to focus, trying to say certain things, trying to remember what I have to say. And then there's also students that are sitting next to you that are trying to listen. And if there's someone talking, it can be one of the most irritating things possible for them. And it's not so irritating to be told not to talk in class, right? I mean, you already knew that, right? Okay, so don't forget that there's a Mobius quiz today. Also, I think today and tomorrow, I'm saying Wednesday to Thursday you should read these. You already read this, didn't you? How many people didn't read this yet? 6.4 to 6.6? Oh, okay. Yeah, I did say Wednesday to Thursday. It's sort of because I want you to be able to focus on your assignments and on the midterm. And because you had the calculus midterm, I didn't want to give you new readings then. But yeah, I mean, now I told you didn't have to read this until Wednesday or Thursday. Okay, well, that might have been too lenient, because then what do I teach? Okay, but anyway, so regrade requests for the midterm, that's due November 3rd, but you might as well get it over and done with tomorrow. Okay, today you've got your assignment, your Mobius quiz, some other things you're reading, but while the midterm is fresh in your head, that's when you want to be doing the regrade request. You don't want to be waiting 2 weeks later, then you forget the questions, you don't know the details. And, you know, if you wait until November 2nd and then suddenly you realize, oh, I forgot I had the CS assignment due, and this Mobius quiz, oh, and this assignment 6, and the calculus assignment, and the other speech communication assignment, oh, and I forgot that I also have a CS midterm. Then suddenly it's November 2nd, you were planning to do the regrade requests on November 2nd, but then you realize, oh, wait a minute, I don't have enough time. So, I'm just saying, just get that over with as soon as possible. And then tomorrow, try to look at assignment 6. Okay? I'm sorry that this course is constant, but that's just the way it is. Now, okay, everyone, I'm extremely proud of all of you for having the courage to come here to University of Waterloo. I'm very, very proud of all of you, no matter what you got on the midterm. Okay? Believe me. It doesn't matter if you got 11%. I'm proud of everyone for having the courage to come here. Okay, it's a big, big step. Most people don't come here. You're one of very, very few people that come to the University of Waterloo. Okay, wear that sweater with pride. That University of Waterloo, black and gold. Well, it's black and yellow in this case, but you know what I mean. Black and gold is the Waterloo colors, right? All right, and I know that you guys have been working non-stop in this course. I know it, okay? So, yeah, I tell you once in a while, like, oh, you gotta work harder, but honestly, I don't know what I was thinking when I was saying that stuff, because I know what it's like to be a student. When I was a student, there was no free time. You have your Mobius quiz. When the Mobius quiz is done, then you have your assignment. Then your assignment's done. Then you have your Math 137 Mobius quiz. Then your Math 137 assignment. Right when you finish that, you have your CS assignment. Right when your CS assignment is over, you have your Math 135 midterm. Right when your Math 135 midterm is over, you have your 137 midterm. You're constantly studying. There's new readings being assigned. There's just no free time, and I know it. And I know that a lot of you, it's impossible to work any more hours than you're already doing because there's not enough time in the day. Arnold Schwarzenegger used to say, if you don't have enough time, then sleep faster. But most people can't sleep faster, right? They can just sleep longer, but they can't sleep faster. All right, so, but that's pretty much what you have to do. I mean, he was right. It's crazy. University is crazy, and that's the way it is, okay? I appreciate that everyone's working nonstop. People are working nonstop and they're still getting 40% on the midterm. That's okay. That's not your fault. That's, you know, some people come into University of Waterloo with a stronger or weaker high school background. And this sort of happens when a high school teacher gives you 100 when you really shouldn't have got 100, or if they give you a 95, but you know, some high schools are stronger than others. That's why you're struggling. It's not anything wrong with you. If you were taught properly right from the beginning, this stuff, you would be getting I don't know what to say. I don't really know what was going on at your high schools, but everyone is capable of doing Math 135, but it's not true that everyone's capable of doing it in the number of hours we give you, and that's just the way it is. We give you a certain number of hours based on what the high schools are supposed to be doing. Okay. All of you should be very proud of yourselves for getting this far, okay, no matter what. You should be proud of yourselves for getting this far. It's a big journey. Some of you have come from the other side of the world all the way here. You should be proud of yourselves for taking that journey for, a lot of people are too afraid to go out of their hometown, and here you are in another country. So I'm proud of everyone for being here. Anyone who passed, thank you for working so hard. It's appreciated. I'm proud of anyone that passed. If you passed, good for you. Like that's really, really good if you passed a Math 135 midterm. And you will likely pass this course if you passed the midterm. All right? What did I say on day 1 of this class? What did I say on day 1? First time I came here, what did I say about Math 135? This, for many people, this will likely be their hardest course. Okay? So if you can pass this, I think you can pass your degree. You can finish your University of Waterloo degree. If you get through Math 135, you'll probably get through UW. Math 135. How many people find calculus harder than algebra? 1, 2, 3, 4, 5. Okay, in the last class there was 2. It's true. I mean, I've met people, even when I was in Math 135, there was people that were saying 135 is so easy, 137 is crazy. And I never really understood that, because in my high school we did limits, we did jump discontinuities, we did derivatives, we did every single thing that was in Math 137, except for sequences and delta epsilon proofs. But the delta epsilon proofs, it's like, if you know limits really, really well, then it's not that much different. I mean, it is just limits. So if you did well in high school calculus, then Math 137 is usually easier than 135. But there are people, I was surprised, I didn't understand it, but there were people that told me, I'm really struggling in 137, and 135 is easy for me. There's people that do computer programming, they're thinking logic all the time, because they have to dumb themselves down to the level of a computer. The computer will not do this unless this is true and this is true, and so they're used to that logic. So how many people found calculus harder than 135? Okay, so there's 5 or 6 people finding it harder. That's okay. For the majority, 135 is the harder thing, and for the majority you find 137 easier than 135, then 138, 237, calculus 3, calculus 4, A-Math 231, all those things, differential equations, A-Math 250, all the courses afterwards, if you find calculus easier than this, then all the future calculus courses, you're good at calculus, don't worry. Math 135, it's a little bit harder, it's a little bit different. It's proofs that people haven't seen these types of proofs before. There's one other course that's mandatory for most math degrees at University of Waterloo, maybe even all math degrees. That's Combinatorics Math 239. Okay, I don't know if I talked about it here, but Math 239, Math 239 is like the sequel to Math 135 in many ways. It's binomial theorem, left, right, and center. If you found question 10 of the midterm hard, that was the binomial theorem, that's going to be combinatorics, left, right, and center. You're going to have like double sums, like sum over x and sum over y, and x is changing like this and y is changing like that, and it's going to be left, right, and center. Combinatorics is going to be similar to Math 135. It's going to be a lot of summation notation and a lot of proofs, a lot of induction. But I think 239 is going to be easier than 135 because you've already been through, here you're adjusting. First week we're already asking you to do Mobius quizzes and you're still trying to like unpack the suitcase and fold your clothes and put them in the closet. You haven't even found where the kitchen is in your dormitory yet. Like, you're still moving in. And then you don't know Piazza, and you don't know how to get help, and you don't have a tutor, you're new to the city, you don't know where the bank is, you don't know where the doctor's office is. Like, So 239 is similar to 135, but because of your academic maturity that you'll have in second year, I think it will be a little bit easier. So 135, I think, is the hardest. After 239, after second year, so second year you're going to have mandatory courses: Math 237, Calculus 3, Math 239, Combinatorics, Math 235, Linear Algebra 2. You're going to have, they're forcing you to take these because they're core basics. Everyone has to know how to do a proof. Everyone has to know a bit of combinatorics and graph theory. But then after 2 years, and I said 239 is probably going to be the hardest second year course for people that find 135 hard. Once you've done those, third and fourth year, you choose what you take. So if you want to take the hardest, like Phil took non-Euclidean geometry, he was spending 60 hours a week on the assignments for non-Euclidean geometry. You can take that if you want. You can take really tough, like whatever the hardest courses are, you can take those. But you can also take whatever you want, right? So you can take easy courses. If you find something really easy, you can just take that, right? There's easy math courses, third and fourth year, you choose what you take. Like it's going to get easier once you can choose what you want to take. Unfortunately, everyone has to take Math 135 and Math 239, and these are a little bit hard. So if you don't like it, it ends up being hard. But if you get through this, you'll probably get through UW. Now look at this. How many people are in Math 135 in total? 1,300. 1,300 on campus, 700 off campus. There's 700 online. You know about the online version, right? There's an online version of Math 135 right now. You guys didn't know that there was an online version?
I thought there was an online version.
Because there's people on Piazza from the online version, and then they get answers. They're like, this is the on-campus version. Ask your questions elsewhere. Because there's people from the online version asking questions on Piazza. So, 1,300 in the on-campus version, 700 in the off-campus version. Even if it was 1,300, does that look like 1,300 students that graduated? You guys have seen this where is this? Have you guys seen this in the hallways?
Not really.
You've seen it? Yeah. Which floor is it on?
I don't know what floor it's on. I think it's on one of like the connecting. Like,
okay, on the DC. Okay. Yeah, so you guys can see this if you walk around the campus enough. In the hallway, you see graduating class. They have all of these different people that graduated. It's not 1,300. Okay, so if you're getting an 11% in this course and it's just not working for you, it didn't work for 1,000 other people either. So I'm just letting you know. It's good to know this as early as possible. Have a think about whether this is, and it doesn't mean that you're not good at math. It doesn't mean you have failed. It really doesn't mean you have failed. It means that your teachers have failed in the past, because this is, or maybe not even that. It's just, this is just normal. Like not everyone, this isn't, Rose, this, you guys are talking. I'm trying to give a lesson here, okay? So yeah, just to let you know, if you do decide that this isn't right for you, it wasn't right for many other people either. The sooner you figure it out, the less time you waste doing courses that you don't really have to do for the career that you end up going in. And yeah, just because you got 100% in high school, it just doesn't mean anything. That's just the reality of it. Because a lot of people in this class are finding Math 135 quite easy. So let's go on. Now, if you got a 75 or higher, you're amazing. Okay, I just want to let you know, if you got a 75 or higher, you're absolutely amazing. I know you're used to getting hundreds in your high school and everything, but it's just forget about it. Completely forget about. I get so many students coming to me saying, I was perfect in high school. I was so good in high school. This is really disappointing. I get third-year students coming up to me saying, I was so good in high school. It's so disappointing. I'm getting kicked out of the biochemistry co-op program because my average is not high enough. Well, yeah, I don't care how well you did in high school. It's just over. It's completely over. This is a new stage of your life where there's people coming from all sorts of different high schools. So if you got a 75 or higher, yeah, maybe you're used to getting hundreds, but be proud of yourself if you got a 75 or higher. Be proud of yourself if you passed, or even if you got an 11%, like just being here, I know, okay, I know 11% is not bad. All it means is that something else, there's a sequence of things that just didn't work out for you. I know all of you are capable of doing whatever I'm capable of. We're all human, we all have the same IQ, okay? It's just, some people have different circumstances and they have advantages, and that's the way it works. So if you got 80 to 100, you probably feel pretty good right now because there's a handful of people that got 80 to 100. Think about how good it feels right now, okay? And you probably enjoy it, okay? So you also have the opportunity to feel this way for a long time if you keep up what you've done. So I just want to keep encouraging people because I know a lot of the people that got 80 to 100, they didn't sleep for this whole term, some of them. They've been working really, really, really hard all along. You know, they've been pushing themselves to the point where they feel like they're going to break. And I'm just trying to tell you, like, think right now. You got 80, you got 90. Think about how good it feels now that you saw your grade and you know that the class average is 63. So it feels good probably. And so I just want to point out, if you keep doing whatever you've done, I know sometimes you feel like you want to give up. It's just crazy the amount of the work that we're asking you to do. But you know, if you keep doing that, it can be very much worth it. Okay, anyone who wants to do better. So you got, yeah. Oh, people thought that was a question. This is a sentence. So this is it's a statement. It's true or false. Oh no. Okay, that's not necessarily. But anyway, I just want to say that if you got an 80 and you want a 90, or you got a 50 and you want a 60, if you got a 60 you want a 70, if you got a 40 and you want a 50, if you got an 11 and you want to get a 40, actually you should. Well, who wants to get a 40 in the course? I don't know. Like if you got 11 and you want to pass, then there is this system. I've talked about it in the past, but I didn't properly show you the site. So the University of Waterloo Student Success Office has this Tutor Connect system. So unfortunately, we've given you a lot of resources. There's the online tutorial center, which is open until like 9 p.m. on some days. There's Piazza. There's average response time 13 minutes. You can ask whatever you want there. People are answering it. There's the office hours. I'm spending 2 hours each week, sometimes even more, doing like one-on-one help to people that come to the office hours. So there's that. But some people, that's not enough, right? Because the tutorial center, there's like 30 people in a Zoom meeting. It just doesn't work for some people. And office hours where, you know, you don't want to ask me questions in office hours because there's other people there. You got to leave, Eric?
No, I was just putting my...
Okay, yeah. So office hours don't work for some people. The timing doesn't work, or there's so many reasons why it might not work. So Tutor Connect, you can find a Math 135 tutor that will help you one-on-one. Or if you have 5 friends, maybe you can pool together and say, we want to get a group lesson, me and these 4 people. So this system exists. I'm just letting you know about it, because for some of you, if you're not happy with your midterm mark, this exists. And there's tutors there. Some of them might be like students, like second-year students. They did well in Math 135, but they don't have any experience teaching. Maybe they're charging like 50 cents an hour. Like, I don't know if that's going to be your best tutor. But there are some people there, if you look at their credentials and stuff, there's people there that have been teaching Math 135 like me for like 15 years. There's people that have been at the front of this room for 15 years teaching Math 135, and then they've had enough of that, and now they want to do one-on-one, help people in a different way. So it's hit or miss. You can go there and look at the credentials of the people on the Tutor Connect system, choose who you think is best. If you have questions or you want advice, like you want to know, like I know a lot of the people in that system, so I know the reputation of certain people in that system. So if you ask me, I can maybe help give some advice about whether or not I know that person has a good reputation or a bad reputation. You can always ask me about that too. Okay, and also I know there's a lot of people think I'm ignoring them right now because they got 100% on the midterm. There were people that got 100 on the midterm. They might feel bored, like, oh, this is so easy. Like, why are you wasting all my time talking about all this Tutor Connect? Well, you know, if you're bored, you're getting 100%. You're bored, you want something to do. Well, this is still, you're paying tuition at University of Waterloo. You do want to learn something, we have given you this system where there's Tutor Connect. There's people that can teach you more advanced math if you want. So, you can contact one of these guys, say, I got 100 in Math 135, I'm bored. Can you teach me complex analysis? Can you teach me non-Euclidean geometry? Can you teach me general relativity, differential geometry, whatever, like 4th year math courses, 2nd year math courses? Can you teach me combinatorics? Can you get me ahead for 2nd year? That kind of stuff. So this is available to everyone, if you're bored or if you want to do better. Now, okay, done with that. Midterm feedback plus grades. So everyone knows how to find this on Learn? Okay, so the midterm grades are posted. Question 1. Here's the feedback for question 1 that's on Learn. So someone else typed this out. Mostly mistakes that amounted to misreading the column headings. By the way, who got perfect on question 1? Almost everyone. Okay, some people, there's 1 or 2 people that didn't get perfect on question 1. So the majority of the people that didn't get perfect on question 1, it was mostly about making mistakes that amounted to misreading the column headings. Okay? And 2 hours before the midterm, what did I say? I said, this column, it's not necessarily related to the previous 2 columns. So you might be used to, you have B, and then here I'm just going to do not B, so this is just going to be the opposite of that. You just look at this and then negate it. And then here it's maybe A and B, so you just look at the first 2 and you do that. Or it might be like, you might think it's B and C, then you do these 2. But here, this might be something related to that and that, or something, right? And I told you this the 2 hours before the midterm. I said that this is the case. These are not necessarily related to the previous 2 columns. What was the biggest mistake? I guess the other sections got it wrong, right? But, well, everyone here got it right. So almost everyone here got it right. So, and those that got it wrong, hopefully it wasn't because of this, because I told you 2 hours before. That's something to watch out for. Next, question 3. Remember, this is what they wrote on Learn. Remember that the negation of A implies B is A and not B. How many people got perfect on question 3? Not everyone. There's a lot of people that got question 3 wrong. Well, hopefully it wasn't because of this. This is what the majority of the Math 135 students got wrong. And look at this, 2 hours before the midterm, I said, negation of A implies B is A and not B. Memorize this. I said, memorize that. Okay? And this ended up being exactly what the hardest part of that question was. So I did give you the advice there. Then for this part, I said make sure you say 5 plus A over... Hey, this looks quite a lot like the answer to the question. What did I do differently here? This was 2 hours before the midterm. I gave you this.
Just the numbers. It was 4 instead of 6, I think.
It was 4 instead of 6 over here? Yeah, so it was the 4th root instead of the 6th root. Yeah. But I told you, any even root. I said 4th power, 6th power. I gave you the advice here, right? So... that's just maybe a tip to pay attention in class. And when I'm not going to put these lecture notes online, right? Because it's just too close to what the midterm actually is. So, yeah, it's important to come to class, because if I give you tips that are that close to the midterm, it's probably best that I don't put that online. Like it's already helping you so much. If I put it online, then it's just too much. Okay. So did anyone get any marks taken off here? Yeah. That was for not saying that the steps were reversible?
I think so.
Yeah. And what did I say about that in the class? Did I say anything about reversibility? Yeah?
Remember, but it's either you said that you should say that it's reversible by saying that you could just plug it back into the equation, or if you showed how you just solve for x, then that should be fine as well.
If you solve for x and then you plug it back into the equation, that's okay because you're actually doing the reverse steps. If you solved for x and you said that every step here was reversible, that's also good enough. But if you don't say that the steps are reversible, Mia?
How do you do that without assuming what you're trying Like if you start with ax minus x to the 6 minus 5 and solve for x,
Yeah.
you're assuming that the original statement is true.
Yeah, and I think it's okay to assume that the original statement is true if you say you're using reversible steps to arrive at this, and then once you get here, then you've proven it's true. So you started with the assumption, and then your assumption was right. You found something, and you proved that it's a real number because 5 plus a over a is more than 0, so this is a real number. Then you have found the thing. Did you lose marks on this question?
Yeah, the marker said don't assume what you're trying to do.
Yeah, I can't go through each person's, every case is different. We can talk about regrade requests a little bit later. The main point I'm trying to make here is that you can assume that this is true, and then if you find x equals this and you plug it back in, then that's okay. And then also if you derive this and you say that all the steps are reversible, that's also okay. You have to say the steps are reversible, because what about the absolute value of x? If you do absolute value of x, then you're making it unreversible now. You're losing information. You have plus 5 or negative 5. If you have negative 5 and you do the absolute value of it, you're losing information about whether it was positive or negative. You can't reverse that step. You do the absolute value of x. You have negative 5. You do the absolute value. You get 5. Then you can't reverse that and get back what you started with. So if you just derive something and you do absolute value of x, or you do square root, positive minus square root or something, there's some steps in there that might be irreversible. And then getting x equals that doesn't necessarily mean that ax to the 6 minus a equals 5, because you've got this thing, but it might not, if you put it back in, you might not get the same thing. So if you argued that the steps are reversible, then, but people only lost 0.5 if they didn't say that it was reversible. How many did you lose, Mia? 0.5? Yeah. I don't know why they took off the mark, but I also haven't seen your question, and I can't look at it right now. So it's a good question, but it's not something, there's a regrading system that I'm going to talk about a bit more later. Okay, but yeah, I told you about this. I told you to memorize that. That ended up being what everyone got wrong. So hopefully it wasn't people in this class that they're talking about here. Question 4. In questions like these, you really want to get rid of the does not divide sign. Does that sound like something I've told you before?
Yeah.
Yeah? Okay. Question 6. Some tried to use induction, which is not very helpful in this situation. Well, some tried to use induction. So I said in the class 2 hours before the midterm, prove that all integers with n greater than or equal to 2, p of n implies n equals 2. I said, what proof method? You all said induction. I said, no, direct. Okay, so I told you that you don't necessarily use induction just because it's proved for all n. Okay, if it's proved for all n, something implies n equals 2, then maybe you use a direct proof because you're talking only about n equals 2. You're not talking about n equals k plus 1. You're talking about n equals 2. So use a direct proof. Most of the people that got this wrong, they tried to use induction. Okay, hopefully no one in this class fit in that category. Okay? All right, now question 9. How many people got perfect on question 9? Small, okay. Anyone that had trouble with question 9? Yeah, quite a lot of people, okay. So a lot of people use the definition of integer divisibility instead of the definition of polynomial divisibility. But is this something I talked about in class 2 hours before the midterm?
Yeah.
I said, does 3 divide 5x squared minus 2x? Well, 3 doesn't divide 5. If x is an integer, then 3 probably doesn't divide that either, unless, yeah, if you somehow had 15 there, but I don't know how you do that with x being an integer. But anyway, yeah, so it could divide that, but most of the time it probably doesn't. But we said 5x squared minus 2x is a polynomial, then we're talking about polynomial divisibility. If we're asking whether or not 2x divides something, we're asking whether or not a polynomial divides something, we're talking about polynomial divisibility. And then I pretty much gave you the question, right? All you had to do was find the p of x in the set of polynomials of x such that f of x equals this thing times p of x. And then argue that the coefficients here, 5 over 3 and 2 over 3, are in the real numbers. So in this case, you wanted to prove that 2x divides f of x. And all you had to do was take the coefficients of the polynomial and divide them by 2 and say that real numbers divided by 2 are still real numbers. Then you have that this is a real polynomial. So 2x divides f of x. Okay, in the scenario that they gave you. It doesn't always divide f of x. If f of x equals 1, then 2x doesn't divide it. But they gave you some conditions on f of x, and this was all it was. It was like 4 steps. That's why I told you in the class, I said, like, don't freak out if your proof is too simple. Okay, so some use the definition of integer divisibility rather than polynomial divisibility. But that was not any of you, right? I think I told you 2 hours before what to do. Now, some thought that they could just prove it for x equals 0 and this was enough. Because we said f of 0 equals 0, then everyone quickly plugs in x equals 0 into that. And then they show, oh, well, f of 0 equals 0, and f of 0 also equals 0 times g of 0. So, yeah, f of x divides 2x g of x. No, it doesn't. F of x equals 2x g of x for all x is independent of whether or not it's true for one value of x. Okay, so you can't just look at x equals 0 and then say it's true for all x. That was the major problem that I saw when I was grading question 9. For question 9, we awarded 1 mark if you discovered that the constant term of the polynomial is 0. So if you discovered that a0 equals 0, you got 1 mark for that. You got 4 marks for the rest of the proof. If you did something like this, let x equals 0 and prove that f of x equals 2x divides f of 0, you got 0 out of 4 for that proof, because this is really bad. Like, you can't just let x equals 0 and then say it's true for all x. It can't get any worse than that. So you get 0 out of 4 if you did that. What else? If you got the proof right, but you didn't argue it properly, like you didn't say that that these are real numbers because an over 2 is a real number, then you might have lost 1 mark for that. I think most people got either, for this question, most people got 0 out of 5, 5 out of 5, or in some cases 1 out of 5 if they showed that a0 equals 0 but they didn't do anything else right. Or they got 4 out of 5 if they got the proof right but they made a couple mistakes. I don't think there was a lot of people that got 3 out of 5. Okay, so now that everyone knows like the main things people got wrong, I think most of this class didn't get these things wrong, right? Because, you know, it says most people got this wrong, but I told you not to do that. It says most people got this wrong, but I told you not to do that. So I think, question 10. All right. Some tried to use induction despite the warning not to do so. What did I tell you in class? Yeah, you guys laughed. I remember you guys laughed. I said if it says not to use induction, then seriously don't use induction. And then I guess some of the people in the other sections did that. But we didn't, right? Okay, good. So now that you know what's going on with the previous, with the marking and what people got wrong, the reasons why they got it wrong, if you do want to do a remark, you've got to do it before November 3rd. I would suggest to do it as soon as possible, because I talked about it in class just now. I'm not going to be talking about the midterm again on Friday, Monday, Wednesday. Like, I have to get on with the course, right? So now it's fresh in your head. I would suggest after you've done the Mobius quiz and everything, try to do the regrade request after that. Now, for regrade requests, you won't get a regrade request. You won't get a regrade for not saying that the steps are reversible. So if you think that you found x equals the 4th root of 5a over a or whatever it is, and you didn't say that the steps were reversible, as far as I know from talking to the question 3 marking team, they're not going to be giving you back the 0.5 that they took off for that, okay? Unfortunately. Just let it be a lesson for the final exam, I guess. Question 4. Anyone who lost marks for doing A implies B or A implies not B? I know someone that did and they haven't put up their hand, so. Anyone that lost marks for doing this? A implies B or A implies not B? No one. No one lost marks for this? Okay, then I guess you don't have to do a regrade request. But I know someone in this class who did lose marks for that. Maybe it's because I already gave them the marks back. They didn't even realize it. But I was looking at some of your marks, just making sure that the other graders were being fair. And I did give some extra marks to people, so you might have noticed that my name is on more than one question. That's the reason why. So if you did write this down and you lost a mark or half a mark for that, then just submit a regrade request. There's really no one that got question 4 marks taken off on question 4? You lost marks on question 4? For what reason?
He said he didn't know what I mean, but I just wrote that A implies B and A implies not B.
Okay, yeah, so submit a regrade request for that and say that in your regrade request you're allowed to say stuff, right, in the email?
Yeah.
The regrade request is just an email, right? So in that email, say the solution for question 2 of assignment 3 was written in this form. Vihang?
I wrote the wrong thing and why did you?
Well, if you wrote the wrong thing, then I'm not giving you a mark for that. So anyone that did this and lost a mark. If you wrote the wrong thing, you're not going to be getting a mark back on the regrade. But if you, I'm telling you this because if you do a regrade request and they find something that they don't like, they're going to take off marks, and you can actually get a mark lower than what you started with. Okay, so if anyone lost marks, there's already one person. I know there's another person, so there's at least 2 people in here that lost marks for this. Just submit a regrade request and say the solution for question 2 of assignment 3 is it says exactly this, and that's what I did. So my solution is at least as good as the solution that you gave me. Okay. Now, how about question 8? How many people lost marks on the induction question 8? No one lost marks? Robin? Yeah, a couple people. All right. Did you lose marks for saying assume that for 1 is less than or equal to r is less than or equal to k, a of r, ar is less than 0? Or is less than 2?
I might have something like that.
Yeah, anyone lost marks for writing this? Okay, Henry? Yeah, so you wrote exactly this and you lost a mark?
I used M instead of R.
But you wrote exactly this with an n here? Yeah, because some people lost marks if they put p of n is less than 2, but they never defined p of n. They would have lost 1 mark, I think. And Jimmy, what happened to you?
I don't think I wrote down for 17 and that, and it was 17.
You forgot to put this part?
I didn't write for 17 and that.
Oh, okay. So some graders also wanted to say for some k in z. All right. The reason for that is because, well, here you're not saying this is true for all k or for some k. You're not saying whether it's universal or existential. So if this were universal, then you're assuming what you want to prove. You're saying it's true for all k, but you want to prove that it's all for all k. So you don't want to assume that it's true for all k. That's what you want to prove. So you definitely don't want to say assume that for all k this is true. And if you don't say that it's for some k, then some people might think that you're saying it's true for all k instead of just for one k or some k. And the graders, they're not, if you're thinking about whether or not to do a regrade request, they're not going to give you back the marks. So if you lost marks for doing exactly what I told you to here, then just contact me directly. Only 2 people lost marks there? Anyone else? So it wasn't that big of a deal. Most people got the marks for doing, because there's various graders. For each question, there's like 6 or 7, sometimes 9 or 10 people that are grading it. So, but that's out of the like 200 graders in total. So it is consistent in that there's a small group of people marking 1 question for each student, but that group, there's variability even in that group. So here 2 people lost a mark, the rest of the class was good. All right, great. If you did lose marks for writing exactly that, then contact me directly because you're not going to get the regrade. Question 9, some people lost 2 marks for not doing the case n equals 0 case. For polynomials, if the degree of the polynomial is 0, you have a constant. Some people wanted you to do that case separately from the other, and they lost 2 marks for it. If you submit a regrade request, I think you'll get the 2 marks back. Because we already discussed for question 9, you don't actually need to do it in 2 different cases. So anyone that lost 2 marks for that, you'll get them back if you do the regrade. All right? For question 10, submit a regrade, okay? Unless you got perfect. How many people did not get perfect on question 10? Pretty much everyone, right? Except for a couple people that got the thing completely right. So so I think question 10, I looked at question 10, several people lost. There's one person that had a whole page worth of stuff where they found that x equals half. They found this, they found that. They actually got they got halfway through the proof and they got a 0 out of 5 with no explanation. So I think that you should just submit a regrade request because I think some people marking 10, I don't know. From what I've seen on Piazza and stuff, a lot of people got 0 out of 5 on question 10, even though they did like half the proof. So I think that regrade requests would be appropriate. There was already one person that got a 1 out of 5 and it got changed to 5 out of 5 already on Piazza. Okay, now for question 10, I gave it to you, right? Look at this. I said, if this thing is negative k, then you do 1 over 5. I just gave you a 5 instead of a 2. Then I said, if you have 1 plus x to the n plus 1 minus x to the n, which is the hint they gave you. They said, use 1 plus x to the n plus 1 minus x to the n. You have this right there. I said, what does that simplify to? Boom, exactly the thing that they wanted you to prove, right? This thing, m equals 0 to n over 2, boom. So I gave you that question. All right. If you still got it wrong, I don't know. Should I not do this for the final?
No, do it.
All right. Okay, maybe I will. Well, I'll try. If I don't get in trouble for what I've put here. So I'm not going to be posting this online for those of you that are asking, hey, are you going to post this online? It's just too much already, right? Okay, so who can guess what we're going to do today, apart from midterm review?
Extended Euclidean Algorithm?
Because that was in the readings?
Yeah.
Okay. So first of all, how many people are comfortable finding x and y when you have an equation like this? Everyone's already comfortable with it? Anyone that's not? Anyone that needs this review? Because it was a little bit fast last time, right? So in the course notes, it's not explained. Like they take 1, 2, 3, 4, 5, 6, 7 paragraphs, like all these equations and paragraphs and stuff. I don't know. Do they really need to write that much? It's confusing for some of the students. Here, we just show it to you. We want to do x 1, 2, 3, 9 plus b plus y 7, 3, 5 equals 504 or something like that. Oh no, equals 21. That's what they want. Equals 21. So we do Euclidean algorithm. We just divide. We get 21. That's the GCD. And then we go backwards. We do something called back substitution. So, back substitution. Here we have 42, right? What does 42 equal to? 42 equals 231 minus 21. Right? So, 442. That equals 504 minus 2 times 231. Right? So I'm just going to put 504 minus 2 times 31. Right there. Then I group, there's 231 here, and there's 5 times 2, 231 there, so I have 11 231s. Then 231 equals 735 minus 504. 735 minus 504. Let's put that in for 231. We put that in. Then we have a 504 here. We have 5 of them there, and we have 11 of them there, so we have 16 of them in total. 16 504. Then 504, that equals 1239 minus 735. So we plug that in for 504. Here we go. Okay? That's one way to find the x and the t. Or the s and the t, whatever you want to call it. That's back substitution. Now remember, there was this final exam question. We had to prove that m divides e in this polynomial. You all remember how to do that? Okay? In the end, we had m divides en to the 4, and we knew that m doesn't divide n to the 4. So we concluded that m divides e. Why is that okay? If m divides en to the 4 and m doesn't divide e, then, m doesn't divide n to the 4, then why do we know that m divides e? What?
I say, is there an hint like on the assignment?
The hint on question 2 of assignment 5? Yeah, what was the hint? Versano.
Wasn't P divides A or P divides B? And then,
If something divides a product.
yeah.
Okay, so we have n divides a, b, and GCD of n and a is 1, so n doesn't divide a, then n has to divide b, right? Who knows how to prove this? Actually, it's written right there. You can prove it using Bézout's identity, right? So you all know how to prove this theorem? It was in the readings, right? So if you want to prove this, you can prove it using Bézout's identity. There's like 3 lines in the proof, right? It's not a terribly difficult proof. The proof of this, that can easily show up on the final. Because if you've done the reading 6.6, for example, or 6.7, there is the proof of Euclid's theorem. There's an infinite number of primes. That was proved in section 6.7, right? Or I don't know, 6.7. So in the course notes, you already have the proof that there's an infinite number of primes. And then, a few years ago, on one of the midterms or finals, there was an exam where they said, prove that there's an infinite number of primes. So anything in the course notes, they say that there's an infinite number of primes, they give you a proof for it, then it can be on the final. So likewise, here's a theorem, and they give you a proof for it in the course notes. Then any theorem in the course notes, they've proven it in the course notes, you can be asked to prove it on the final. That should be the easiest question on the final. You should just, anything in the course notes they've already proved. You've already memorized the proof anyway, so you should just get 10 out of 10. Do that question first, because it's really easy. Okay, so this theorem, you can prove that using Bézout's identity. That's one way you can do it. Now for some review of the readings. So floor of negative 9.001, what is that equal to?
Negative 10.
How many people think negative 10? How many people think negative 9? Okay, in the other class I asked it the other way around. I said, how many people think negative 9? Everyone puts up their hand. And then I say, how many people think it's negative 10? So this can throw you off because 9 is the closest number, but floor is the closest number below, is the first integer below, right? So if it was floor of 9.001, then what's the floor? 9, yeah. But if it's negative 9.001, then it's negative 10. What's the ceiling of negative 9.001? Negative 9. So you already know the ceiling even though it wasn't in the course notes. You know it from high school. Oh, I thought that was you that was saying. Oh, it was Eric that was saying. Someone in the front row was saying.
No, 137.
137.
Oh, I'm reviewing easy stuff. Okay. Floor of this. I don't even need to review this then. It was in 137. What's this equal to? 3. Okay. Wasting my time in doing that. So, extended Euclidean algorithm. How many people know it by now? Some people don't. Okay. So, here we have let D equal GCD of 2172 and 423. You want to find a certificate of correctness for D. What does that mean, a certificate of correctness? Page.
The S and the T that go with Bézout's identity.
Yeah, so basically 2172S plus 423T equals D. The certificate of correctness is the S and the T. So they ask you for a certificate of correctness, then you find the S and the T. How can you find the S and the T? What we just did? What did we do? Versano.
Didn't it involve the backward substitution?
Yeah, so you have 2172x plus 423y. You can do the Euclidean algorithm to get D, which is the GCD of them. the Euclidean algorithm, just divide 100 times and then you get D. And then you do it backwards, so that's back substitution. You basically see, okay, I start with 21, which is the GCD. 21 equals this. 42 equals 231 minus 5 times this, which I have here. I have that there. And then 231 equals 504 minus 42, 2 times 231. Oh, 231, I use this one. 735 minus 504, so that's what I get here. Right? And then here I have 504, so I get 1239 minus 735. So that's the backward substitution. And then, well, instead of doing the Euclidean algorithm to get D, and then backward substitution to get the certificate of correctness, you could just do the extended Euclidean algorithm. So it's putting it all into this table. And if they ask you to apply EEA, the extended Euclidean algorithm, you're not going to get full marks for doing back substitution, for doing Euclidean algorithm followed by back substitution, because they asked you to do it in a specific way. So now you're going to have to actually use extended Euclidean algorithm, which means you draw out this table. X, Y, remainder R, and then Q. So this is when you're dividing things, you have a Q, and you do it all the way until your remainder is 0. Is that right? Okay, and then when you're done, then here we have the certificate of correctness now. We have, for Q equals 1, we have 2172, which is what we started with, times 52, which is the last thing we have in this table, plus 423 over here, minus 267. That's the last thing we have in this table, right? So you just start off. You put 1, 0, 0, 1, 2172, 423. You put these two there. That's what you start off with. 1, 0, and then A. 0, 1, and then B. Okay? And then you do your remainders, your Q's. You know the logic already. You've done the Euclidean algorithm. You've done backward substitution. Now, this is just a convenient way to get your S&T without having to do the back substitution and the Euclidean algorithm both. Okay, you just put it into a table. It's just a neat way of doing what we essentially did over here. Okay? So that's the extended Euclidean algorithm. Okay, so I ended at 450. And any questions about extended Euclidean algorithm? Okay. Okay, I know the mood is low for a lot of people after getting the midterm results. I know, I completely know. I completely appreciate what's going on. I know what's going on. Just stick with it, because if you pass Math 135, you're probably in good position to get this degree. As long as other things, you have to keep working hard, and as long as other things don't happen, like you get offered a job and you start working full time at the same time as this, or as long as something crazy doesn't happen. If things keep going the way they are, then I think that you'll be able to get through this.